So we move on past the Earth to Mars, the next planet out. Also known as the red planet. You can see compared to the Earth, it's also quite a lot smaller. It's around about half the size of the Earth. And when you look at it with the naked eye, it actually has a definite red colour. You won't see Mars until about February or so of next year. So it's still quite a long time before you can actually see it in the evenings. And it's got two moons. At this scale, our moon is this big. It's two moons of the size of a pinhead. And they orbit at a distance of about this far. So our moon is out over the door, and Mars has two pinheads orbiting around about this distance and this distance away. So much, much closer and much, much smaller. Actually not much more than just captured asteroids. When we look at the surface with some of the probes that have gone past, we notice, like Mercury, it's covered in craters. Lots and lots of them. There's actually more than 43,000 craters on the surface. And when you get down to the surface, it's rocks. Basically as far as the eye can see. Now back in 2003, you've probably heard of Spirit and Opportunity. They landed on the surface of Mars. And originally, they were supposed to be there for about 90 Martian days, what they call a sol. It's actually been there for about 7 years. They're not doing much now because one of them is basically can't move, and the other one, I don't think it can move much now either because the wheels are worn out. They really need a good clean of the surface, but they don't have anyone up there to do an oil change, so they're just stationary, weather stations, or that if you like. This is a panorama of Erebus crater taken by Opportunity. And you can see there's a lot of sedimentary rocks. You can see these are obviously laid down in layers. And then it's been worn away with weather, or it's actually a crater, so a meteor has hit it, and then the weather has sort of weathered the surface as well. Then in 2005, NASA released a picture proving that there was water on Mars. Now they had other photos of this one that they took, and you can see, this is looking straight down, you can see that this ground is obviously layered. It's been laid down in layers, like Danish, layer upon layer. And then sometimes something's come through that released water, it's come through in a huge gush, flushed a lot of this material away and leaving these various layers of material to show that there must have been water there to lay all this dust and dirt on layers rather than just one continuous, like from a volcano or something like this. So they know there's water on the surface of Mars. Who hasn't received this email? In August, Mars will appear the same size as the Moon. It comes around every August. I actually didn't get one this year, but they always come around. But there's a grain of truth to this if you go back and you trace the history of it. In 2003, Mars was at its closest approach to the Earth for 5,000 years. And when viewed through a telescope at a magnification of 75 times, it would appear to be the same size as the Moon is with the naked eye. All of that's true. That is all true. However, like most things on the internet, as they go through many, many iterations, people remove bits and pieces over time. So someone took out a little bit about 2003. They left August. They took out another little bit about you need a telescope. Took out a little bit about you actually need to magnify it 75 times. And took out a bit that the Moon is just through with the naked eye. Leaving these words of wisdom, which is what's in the email. In August, the planet Mars will be at its closest approach to the Earth for 5,000 years and will appear about the same size as the Moon. Unfortunately, all these other bits were removed. So true. Because if you look up in the sky and you see Mars is the same size as the Moon, you better duck because it's coming this way. So after Mars, you get out to the asteroid belt. And the four largest, you can see the biggest one here, Ceres, is nearly 1,000 kilometres across. But if you were to put all of the asteroids together, you'll get 4% of what the Moon weighs. And unlike all these pictures that you see in the asteroid belt, the average distance between asteroids, like largish ones, a kilometre or so, the average distance is 1 million kilometres. So 3 times the distance between the Earth and the Moon is how far each of these asteroids are. Which is why there's sent many probes through there and they haven't hit anything significant, other than little specks of dust perhaps. Their Ceres is the biggest. And when it was first discovered, they thought it was a planet because it seemed to fit in that gap between Mars and Jupiter. But then they realised very quickly that because it's so dim, it must be quite small. And we now know that Ceres, compared to the Earth, is that big. Admittedly, this is about the size from Melbourne to Sydney. You imagine a single rock stretching from Melbourne to Sydney. So in its own right, it's still quite large, but that accounts for 1/3 of all the material in the asteroid belt. So all the others put together are only twice that size. So you see, it's not particularly big. And of course, some of these rocks find their way to the Earth and they land on the surface and they make big holes in the ground, like this one in Arizona. Right, this is about, from one side to the other, 1.2 kilometres. That was made by a rock around about 30 or 40 metres in diameter, so a bit bigger than this room. Made a hole more than 1 kilometre across. This is my meteorite. If anyone here was from my talk last year, they would have seen Aussie as well. So I brought him along for the drive again. He actually landed in Argentina about 4,000 years ago. And he's solid iron, about 98% pure iron, most of the remaining being nickel. Magnetic, of course, nothing exotic. The same sort of iron that your car's made of. You can come up later and you can have a look at it, take a photo, whatever. You will need both hands to lift it. It weighs 11 kilograms, it's much, much heavier than it looks.
Trevor?
Yeah.
It's what they call star iron, isn't it? What Smith is used to make a sword of a very high strength.
It's a very, because before the Iron Age, civilisations that lived in areas where this iron was were making implements out of iron, while other parts of Europe were in the Bronze Age. They were making iron because the iron is very, very pure. And so you can heat it up and bash it into knives or whatever you want. So, which is the only way you get iron in a natural, almost pure state, because iron rusts away very quickly and it doesn't stay on the Earth in that natural state normally. Certainly not for very long. Next one out is Jupiter. As you can see, compared to the Earth here, if I had Jupiter, it would fill quite a large part of this room. Right, it's probably almost full size, because if I put the Earth here, actually, it must be very close to the right size. Yeah. So that's how big Jupiter would need to be. I thought of ideas of making a blow-up Jupiter like that, but the one thing I couldn't work out, I thought of having, compressed air or something and pull the thing and it inflates. But I figured if you get a ball like this, could be a weather balloon, and when it inflates, all the people in the front row get knocked out. And all the fluorescent lights get broken and everything. It's probably not a good idea. So I don't have my scale model Jupiter. I have got one, but he only just fits in the cars and in real. Now, an interesting thing with Jupiter, it's also visible when the sun goes down. You've got Venus over here, you look to the other way, into the east, where the sun comes up, you'll see Jupiter. And Jupiter is quite bright, not as bright as Venus, but it's actually been visible for a couple of months now. And that will steadily get higher and higher. So when you go out at night, you'll see this bright star sort of there somewhere. That's Jupiter. If you get your binoculars out, you'll actually see the moons. You may see all four of them, or you may only see a couple of them. But sometimes they're around the back and you can't see them, or they're going across the front. But even with very, very, very small binoculars, you can see them. It's interesting that the four moons are actually visible to the naked eye, if it's dark enough, if Jupiter wasn't there. But Jupiter's there, so you just can't see them because it's much too bright. Now imagine Jupiter whizzing around the sun. Because it's so big and so massive, it actually pulls the sun, makes it wobble. The centre of gravity, what they call the Barrett centre, is actually outside the surface of the sun. So the sun actually wobbles more than its diameter by 47,000 kilometres, which sounds like a lot compared to the 1.4 million. It's only just above the surface. But Jupiter actually pulls the whole sun off balance as it goes around. Remember that because it's useful for later. So you've got Jupiter so massive. What would happen if all the planets went on a line? Wouldn't it tear the Earth apart because you've got this massive gravity? Well, all this was worked out by Isaac Newton hundreds of years ago. He did all the calculations. We can put all the masses in there and you get a little bit of math. If we reduce all that down so you don't have to calculate it, we get to this. And we find that Jupiter has a gravitational pull on the Earth about 1% of what the Moon is. Only 1%. Add all the rest of the planets together and you get 1.7. So the Moon is nearly 20 or about 20 times, 50 times stronger than the gravitational effect of all the planets together. So the likelihood of the Earth being torn apart is just like impossible. It doesn't stop people from writing books about it and forming religious groups and all this sort of stuff, but it's not going to happen. Next planet now is Saturn. And of course Saturn is best known for its rings. And it's the only planet that when you look at it through a telescope, it actually looks like it's a picture. So when you look at Saturn, you actually do see the rings. You might see a couple of moons as well, but you do see the rings. You see a bit of colour. Unlike all the other planets, you look through a telescope and you go, is that it? You look at Venus and it's a big white dot. Well, it's a little white dot. Very bright, but it's just a white dot. Mercury is an even duller dot. Saturn, though, you do see something. We go out to the next one, Uranus. When you look through the telescope, all you see is a very, very tiny version of that. You see a little green dot, and that's it. Boring. Absolutely boring. So we move on to the next one, Neptune. And Neptune is the last planet. It's the last of the giant planets, and it's the last of the planets. But just because it's last doesn't mean it's least. Doesn't mean that it's insignificant or anything. Because compared to the Earth, this is how big. That's how big Neptune is compared to the Earth. It's about 4 times. Yeah, Uranus is pretty much the same size, slightly bigger. But this is about how big the planet Neptune is at that scale. This is a thing they call a Hoberman sphere. You can pack in a whole heap of surface area in a very small volume. So it's about 4 times the size of the Earth. But when you look at a telescope, it's just a boring blue dot, even smaller than the boring green dot you saw earlier. And it also just celebrated its first birthday. It's actually done one complete orbit of the Sun just in the last, just a few months ago, since it was first discovered. So, in our terms, it's 1 year old.